Okay, it looks like a few people are still working on this. Would you like me to, if you're stumped with anything, if you're hitting a roadblock, call me over and I can take a look at it with you. Otherwise, we're going to go ahead and get started in just a couple more minutes here. Okay, so please continue working, but I'm going to go ahead and dive in and start looking at some of these results. So our original Plotly Dash app has a grouped bar chart showing embarkation by survival and also by cabin class, so 3 variables. And it's interactive because you can change, using the drop-down, the variable of interest. And in each one of these versions that you've slacked out, this is excellent. On each one of these, the drop-down has changed, and also in multiple cases, the X and Y axis and Z axis have also changed as well. So this all looks excellent. Let me go ahead and, great, pull up the code in Atom and talk about a few things here. In my note, I said focus especially on line 51. So here's our code in Atom. And there's a lot of pandas work going on in this one. We read in our data frame at line 18. We do some remapping of the sex variable so that female is 1. And there's also some remapping of the cabin class. And then there's a list of variables to choose from, and those are the exact variable names, and that gets used a little later down. In our dropdown, we have this list comprehension that builds out a dictionary. You can, of course, have done this the long way and said options is equal to a list where label is equal to, and I'll just do a couple of these here. Label is survived. Value is survived, comma, and then you would have another dictionary and another dictionary and then another one, and each one of these would be not survived but female, fair, and embarked. So this long form is a lot easier to read than the list comprehension, but the list comprehension in line 29 has 2 big advantages. One, it's just more efficient. It's a single line of code. But the second is that it has this built-in for loop here for I in variables list. So if I ever want to change my variables, I can just update line 21, and I don't actually have to update line 29. If you were to go with the long form here that I just spelled out, then of course you would have to have updated each line manually. And the value, of course, is the default value that the dropdown starts at prior to any selection being made. But the real action is going on down here in line, what is now 47, because I added a few lines to it, which is the group by. We talked a little bit about group by the last 2 classes. A group by is where you take a continuous variable and you aggregate it according to one of 6 statistics by a categorical variable, or sometimes multiple continuous and multiple categorical. So in this case, the continuous variable is to be selected by the user based on the dropdown. The categorical variable has been hard-coded in to cabin class and embarked, and the aggregation method is, of course, mean. Any of those 3 things is open to being changed. And in each one of the examples, it looks like everybody successfully changed the continuous variables. And in some cases, also changed the 2 categorical variables. Now, what would have been really exciting here is to build out an app that had 2 drop-downs, one for selecting the categorical variables and the other for selecting the continuous variables. And that would have provided even greater interactivity to the end user. But that's a project for another day. And possibly a 3rd drop-down where instead of just the mean, you could have chosen maybe some other statistics, the minimum, the maximum, the median, the count. So potentially 3 different drop-downs in order to make the graphic as customizable as possible. And then here is our standard figure code. The big difference is that the x and y variables are now being called using the pandas.loc method that we saw in Tuesday's class. The x values are the index, and the y values are the actual numeric values aggregated by the cabin class. First, second, third. Did anybody choose something other than cabin class and then update the hard-coded values that are here in the .loc? Or is there anybody that did not use cabin class but used something else? You're trying to do it now. Okay. Max, which one did you use?
I did sex and I put male and female, so first and
And then you would have gotten rid of the third my data, right? Okay. And Megan, I see you nodding your head. Did you also do that?
I did. I made a new
Okay. Great. And then finally, the title can be updated with the name of the continuous variable so that it doesn't have to be hard-coded. For what it's worth, I have done a fair amount of hard coding in here, such as the first, the second, the third labels. As much as possible, you want to automate that kind of stuff by actually calling from the values of the variable. So if you had done something like, instead of first, you could have done something like df cabin class dot value counts dot index, right? And then you could have set this to some variable, myvar. And then instead of saying first, I could have said myvar 0. And that would have automated it. It would still produce the word first, but now if for whatever reason I wanted to just replace this variable, then the labels would have updated automatically as well. So it's just kind of a nice best practice in terms of hard coding as little as possible and only when you absolutely have to. Any questions or observations or opinions about this this exercise? Yeah, Max.
So that would, like, hard code, I mean, that automated like that would only work if you chose another variable that had like 3 different.
That's a very good point. Yes.
So you have to do something to like put that array. Truly want to.
That's true. So with sex, for example, there's only the 2 values that you did.
Right, so wouldn't it, like, if you had my bar 2, index 2.
Right, down here it would have been myvar 2, but then that would have caused it would have caused an out of range with the sex variable. Yeah. And sometimes you can do a certain degree of trade-off. You don't automate everything, but you automate a lot of it so that if you do need to make a manual change, you only have to change line 49 and then maybe delete this so that it reduces the amount of manual changes. Obviously, full automation is, what's the word for it? It's an ideal, but it can be difficult to achieve. Yeah.
The .loc.
I sure can. Though it is in some ways better displayed in a Jupyter notebook so you can immediately see the results. We did talk about it, but not a whole lot in Tuesday's class. So it is quite new. And I'm wondering if tonight's notebook actually has some of that. Let me do this. As we get into the Jupyter notebook, I'll make sure to pause for a little bit and do some examples of how to use .loc. Okay? All right. So great, moving on then. And Dominic, yeah, your results. Okay, and you also chose to do male-female, excellent. By port of embarkation and survival, cabin class, fare, and age. Great. Okay, so our repository tonight is repository 10, pandas EDA part 2. Go ahead and respond in Slack when you have Jupyter Notebook ready to go. We are going to look at the drinks exercise, file 04. All right, so let's dive in. The solution notebook is here. I'll be following this code with jumping over a few parts that I think are repetitive. And I'll be live coding in a new notebook. Oops, that's not what I wanted to do. Okay, so this is 10 classmates. And this is EDA pandas part 2. And I'll make it a little bigger. There we go. All right, so our data set tonight is the World Health Organization alcohol consumption data. There's a link to where you can get it from. And we'll start with import pandas as PD, import OS, import numpy as NP, and from pathlib import path. And just to double check, am I actually recording? It looks like I am. Great. Hello, people listening to the recording. So let's find our data. I'm not going to break it out over multiple cells this time. I'm just going to do it in one blow. A little breakout. So data directory is going to be equal to path.join path current working directory parent data, and run that, and then os.list directory data dir, and this will show the contents of the data directory. And we see we have several of the same files that we've seen in previous examples, and I will do tonight what I did on Tuesday, which is do a long run of the walkthrough of this notebook, and then the last 30 minutes display a summary of what I did on the screen and ask you to do the same steps, but with one of these other data files. So we're interested in drinks. Read in the data set, and I'll call this path to data is equal to path.joinPath. So I'm going to join together data dir, which I defined earlier, and the CSV file drinks. And then I'm going to call my data frame tonight drinks, or you could call it df, or you could call it something else. Pandas, read CSV, path to data. And I guess I'll end with drinks, and we'll just sample a few here. Let's sample 3 rows. And hopefully everybody sees what I see as well. We've got countries, and then these columns represent the average servings of alcohol per capita per year. So can somebody take the number 240 and put it into a sentence? Interpret that for me. Exactly. And in Algeria, the average Algerian has only 25 servings of beer per year. The total liters of pure alcohol, I'm actually not sure what this is. I assume it's the same, which is the average liters consumed per person per year of alcohol, but I'm not certain that's the case. And then on the far right, we've got our continent, we've got Oceania, Africa, and we've got some missing data, NaN, for not a number. More on that later. So typically the first question I ask myself when I open up a data frame is, how big is my data frame? Drinks. Shape, we've got 193 countries and 6 columns. And also, what are the column types? So for that, it's drinks dot D types. Country and continent are both object, which means string, by the way. It's referred to as object because the idea is it could be a string, it could be an integer or a float, it could be any data type, so it's clearly a mixed data type. Even if it's all strings, if everything in the column is a string, it's still listed as object. But integer and float obviously represents pure numbers with and without decimals. Just a quick reminder about the 2 ways to call a column in pandas. You can call drinks. This is the preferred way, the kind of best practice way. Drinks country dot value counts, for example, and we'll do a head on that. I think I'll do an ascending equals false. So that's one way. I'm going to copy the same code, and I can also call country as follows with the dot notation, and I get the same values. So this is, I'm going to call this best practice dot notation. And then the third way, of course, is the formatted as a, or just the formatted version. If you put country into double brackets, then you can't call value counts on it, of course, but you can call head. And this allows you to select 2 variables. So perhaps country and also beer serving. So these are basically the 3 ways to call, but the big 2 are the bracket notation and the dot notation. Older code uses dot notation because when Pandas first was launched, that was the only option. Newer code will use the bracket notation, and the difference is that though for the most part, everything you can do with dot notation, you can certainly do with bracket, the reverse is not true. There are a lot of things that you can only do with bracket notation, so you limit yourself in some ways if you use dot notation. Though the argument in favor, of course, is that it's less typing, so your fingers get less work. Sometimes in the code that is provided with the class, you'll see dot notation because that comes from an older instructor, but I will always use bracket notation. Okay, let's do some exploration. Filter to include only European countries. And as I write these out, I'll try and write the comment. You don't have to copy the comment, but do try and think ahead. Oh, where's he going with this? We've seen this a couple of classes now. See if you can figure it out before I put it up on the screen. So if I only want Europe, probably the column I'm going to be interested in is going to be continent. How do I filter only to that? Well, continent is equal to Europe will give me a set of Booleans, trues and falses, and then I put that into brackets and I apply it to the data frame as a filter. Remember, filters are indicated by brackets and lists are also indicated by brackets. So now I see only European countries, Albania, Armenia, Belarus. If I wanted to limit that to Asian countries or to South Pacific, etc. And of course I can call head on that as well, shorten it up. Okay, double filter, only European countries with high wine consumption. So Italy and Spain, for example, are definitely going to be in here. So we start with our original drinks continent is equal to Europe, and we get that set of Booleans. And then we add to this drinks wine servings is going to be greater than 300. So these are people who are drinking pretty much a glass of wine every day. And again, we get a set of trues and falses. And we're going to combine these two into a single filter by putting each of them into parentheses, dropping them into a single line, and then combining them with the ampersand. If I run those together, I also get a set of trues and falses, but now it's the combined set of true and falses. Put that into brackets, call it on the data frame, and ask for tail. And now we've got Andorra, France, and Portugal. These are actually the only three countries. Curiously, Italy is not in there. I would have expected that. Are those the only three? Yeah, because the tail would have been 5. I guess maybe you have to drop it down a little lower to get Italy in there. Let's take a look. 270 maybe? Okay. There's another question that you might ask yourself as you explore your data. What's the average beer consumption for all Europe? How would you do that? Well, we know that average consumption is just drinks, beer servings, and notice how I can use the tab to autocomplete .mean. So that means for the entire world, average beer consumption is 106 per year. But how do I get it down to just Europe? Well, I'd go back up here to my earlier code, drop it back in, and now I've got this data frame of European countries. Notice I kept the parentheses even though they're unnecessary here. And now I want to limit this to a single column. So I limit it to, using tab for autocomplete, beer servings. Come on. Okay, tab for autocomplete doesn't work there, and I don't know why. And then I call the mean of it. And in Europe, the average beer serving is 193 glasses per person per year, with a lot of sevens afterwards. How do I get rid of those sevens? Well, I can call this EU beer, so I've set it equal to a variable. And then I can simply print, or even don't worry about the print, just round EU beer, comma 2 to 2 decimal places, or to 3 decimal places, etc. And of course, I could have done that in one blow. I didn't have to reassign it as a variable, but sometimes that extra step makes the code a little easier to read, that much more clear. Okay, another exploration question. Which 10 countries have the highest pure alcohol consumption? So we can sort the entire data frame by using a sort value. So I can call drinks dot sort values, and we get an error message here saying that it is missing the by argument. So in here I can specify that I want to sort by total liters of pure alcohol, which is an awfully long name. And now the entire data frame has been sorted, starting at 0 and then ending at Belarus with 14 liters per person. But if I want the top consumers, then I need to add ascending is false so that it goes from largest to smallest. And then just simply call a dot head to get, in this case, the top 5. So let's say it's not 10 countries. It's easier to read if it's just 5. But really, I only want the country. I don't want all of that other information. So right here in front of the head, I can simply call the country variable. And now it gives it back to me as a nice little truncated list together with the index. And I wish there was a way to make this a little more visible. Maybe if I do it a little smaller, does that make it easier to read? And of course, if you don't want the index, you simply add the dot values at the end, and it gives it back to you as an array. Or if you really want to clean it up, then you can turn it into a list. But the heart of it is drinks.sortValues by pure liters of alcohol. That's the heart of what I did. And everything else is just sort of cosmetic around that. Okay, column activities. Rename columns. We did see this earlier, but so as we saw a second ago, some of these columns have really long names. Let's shorten them a bit. Drinks.rename columns is equal to a dictionary where we've got beer servings, and I want to shorten this just to beer, and wine servings, I'm going to shorten this one just down to wine. And then I run this, and here I see beer, and here I see wine. But then if I call drinks.head, it didn't stick, it went back. And that, of course, is because I needed to add in place equals to true. But here's the trick. If I run this again, I'll get an error message because now there is no column named beer servings. Okay, I don't get an error message. I thought it would, but it didn't happen this time. Other times in place will cause an error message, but in this case, I guess it just ignores the fact that there's no such column. Which is a good moment to also remember that instead of using in place, you can also reassign the entire drinks variable, data frame rather, and then you don't need in place. And that'll also do the same thing. So either of these two methods is perfectly acceptable. Though it is a best practice to add copy. This, when you reassign a data frame to a new data frame, it's a good idea to use the .copy, because if you don't, and then you both of them are still in memory, the old version and the new version, especially if they have different names, this will occur. And if you make changes to the old version, in some circumstances, those can port over to the new version. So if you reassign and use .copy, you kind of protect yourself from that cross-pollination accidentally happening. But this is kind of time-consuming to have to spell all of them out. What if I just wanted to replace all of them? Make a list of the new columns. Country, beer, spirit, wine. Liters is especially long. Continent. And then read in the data frame, specifying the column names at the read-in. Drinks is equal to pd.read CSV path to data, comma, names equal to new calls. And now I can drinks.head. And this option for pd.read CSV is a quick way to just reassign all of the column names in one blow without having to build out the dictionary the way we did in cell 43. It is important, however, that it has to be the same number and the same order, right? So if I gave 7 names and there were only 6 columns, this would not work. Go ahead.
First row, is that
Oh,
normal?
I'm sorry about that. You're right. Look, it did actually take the... I forgot about that. Right. So in order to avoid that, we need to set header equal to 0, and that gets rid of it. That tells it that the first row of data is the header, and then overwrite the header with the new column names.
And so order matters in the list of column names?
Well, not necessarily. I mean, I could have given it a different order. I could have said wine, and then I could have said beer. Of course, the problem with that is that now the data remains the same, but the labels have been swapped. So yeah, order definitely matters, because the order of your names has to match the order of the columns. You can also replace column names without rereading the data set. So right now, drinks.columns will display the column names. But suppose I have a new list, and I make it equal to A, B, C, D, E, 1, 2, 3, 4, 5, 6. That should work. Then I can simply say drinks.columns is equal to new list, and then call drinks.head. And this reassigns the column names without having to read back in the entire data set. But I do actually want those old names, so I'm going to rerun cell 47. Okay, questions up until this point? Observations, comments? Does anybody need me to go back and redisplay any cell? I know in some of the feedback on Tuesday, a couple of folks said I was moving a little quickly in terms of scrolling through. Okay, cool. Let's keep going then. Again, at 8 o'clock, you'll be doing all of this again, but with a different data set. Okay, so what if I want to remove some columns? So right now, drinks looks like this. But suppose I'm really only interested in beer, spirits, and wine, and I don't want the liters column. I can drinks.drop liters. Now, if I run this alone, I'll get an error message. And the reason why is because it's asking me to specify the axis. Am I to drop this, or pandas is asking, am I to drop this vertically or horizontally? So I tell it I want axis equal to 1, to say drop everything in the liters column vertically. And that works. And now we only have beer, spirit, and wine. But of course, I need to either reassign or indicate in place equal to true if I want it to stick. And now I no longer have the liters column because I have used the drop method. When I first got started with this, I was constantly forgetting about using axis, and I couldn't remember whether axis was supposed to be 1 or 0. So my trick for remembering that is, if you want to drop things vertically, vertical looks like this, and the number 1 also looks like this, right? So 1 is vertical, 0 is not vertical, so it must be horizontal. And of course, you can also drop multiple columns. But you would just add them in as a list. So let's drop beer, spirit, continent. Oh, because I forgot my axis, duh. And now I just have country and wine left. But I didn't use in place, so it didn't stick. Okay. Missing values. Always a big part of any EDA, and something we've seen a few times already, but we'll do a little recap of right now. So, does my data frame have missing values? Drinks dot is null dot sum shows me that I do in fact have 23 missing values for the continent variable. Well, what are they? Let's take a look at value counts. So value counts by itself will simply show the valid continents: Africa, Europe, Asia, Oceania, South Africa, South America. Obviously, what's missing is us. And the reason why is because the default value in value counts is drop in A is equal to true. It's the default, so you don't have to specify it. But if you want to see how much missing value there is, you set drop in A equal to false, and now not a number has been brought back in with the value of 23. Just a reminder that the opposite of is null is not null. So you could have also done drinks not null dot sum, and you would have gotten the opposite. This is everything is valid except for the continent variable has only 170 valid values. And let's look at the rows with missing. We would have added drinks continent is null is a set of Booleans, and then you could apply this as a filter to drinks, and then this will show us only the rows where that column was missing. This is similar to what we saw earlier. So instead of is null, I could have said equal to Europe, for example. And that worked quite well. Is null is the equivalent of a double equal sign. A beginner mistake is to search for this, NaN. But of course, that will give you nothing because NaN is not actually how missing data is coded in this. So is null is the equivalent of the double equal sign. 7:30, about halfway through, so that is about where I want to be right now. Of course, we're just done ahead on that. So why are they all North America? Right, only North America stuff is missing. Why is it North America? Because when we read in our data frame, we read in drinks was equal to pd.readcsv, path to data. We said header was equal to 0. We said names was equal to new calls, was that right? And then drinks.head. Yeah, so we did all of that, but there is a default setting here, which is NA filter equal to true. And we didn't even realize that this was running in the background. It's a pandas setting on pd.readcsv, and what it does is any value that is coded as NA or NaN as a string is actually read in as if it were missing data, which I actually think is not especially helpful because I can think of all kinds of examples where there might be data coming in coded as NA that I don't want it to be null, but that's how they wrote the package, so we've got to live with it. If this is happening to you, you need to turn it off by setting the NA filter to false. Keep in mind that NA filter is exactly what it sounds like. It's filtering for any reasonable version of NA, N/A, or N.A, etc. And now when you do that and you set, let's see if we can do this with a sample maybe. And now North America, now that we set the NA filter to false, we see that North America is actually coming back as a valid continent. So it's no longer missing data. But for the sake of argument, we're going to set it back to true so that we can do a few more tips and tricks with missing data, which is what if we just drop our missing data, which is a very frequent occurrence. Simply drinks drop in place equal to true. So let's go ahead and print the size of our data frame before and after. Drinks.shape before and print drinks.shape afterward. And we see that we went from 193 rows to only 170. We just dropped every row. What drop NA is doing is any place that there's even one cell of missing data, it drops the entire row. Sort of the nuclear method, not necessarily the best approach. I'm going to go ahead and read back in my data frame again so that I have my missing data back. And this time I'm not going to use nplace so it doesn't override anything. You can use drinks drop NA how is equal to all, which will actually protect it. What all does is it only drops when the entire row is missing. So this actually won't drop anything. The opposite and the default is how equal to any. So let me put a comment in here. Drops if an entire row is missing. Drops a row. Drops a row if any cell of row is missing. So those are the two big types of drop in A. And here it prints the output, but it doesn't actually do that because I didn't specify in place. Much more useful is to fill NA with a reasonable value. So we already know it's North America. So rather than turning my NA filter off, I could have simply replaced those missing values with drinks.fillNA value is equal to North America, but of course I have to specify the continent. And we'll go ahead and set that in place equal to true so it sticks. And then drinks.sample, see if it worked. And it did, it rewrote St. Vincent and the Grenadines as North America. But really I just wanted it to be NA. And the second time, of course, it doesn't work because I've already filled the NA. So I need to go back and rerun my pandas read CSV. And now that sample actually didn't get anything. Neither did that. There we go. And now Mexico is correctly coded as North America. So fill NA is I guess the preferred method for handling missing data, but it is under many circumstances reasonable to drop your rows with missing data as well. Okay, let's move on then to group by techniques, similar to what we did in the Plotly Dash app tonight. Group by is probably the single most frequently used pandas command out there. And the reason why is this is what everybody wants from their data. They want you to summarize it. They want, look, give me some summary stats by a few key groups or interest groups. So group by is going to be your best friend there. It's the equivalent of group by in SQL or pivot tables in Excel. So calculate mean, let's say average, here by continent. So you'll remember that earlier we simply did drinks.mean, and that gave us the mean of every numeric column in the data set. And if we wanted to break it down to a single column, we had to specify average beer consumption. But now we'd like to follow that up with a group by statement. So I'm going to take my drinks data frame, I'm going to call the group by method, and I'm going to specify the categorical variable. Beer is a continuous variable. The categorical variable is going to be continent. And then after that, I simply use this same code, beer.mean. And now it breaks it out by each of the 6 continents, average beer consumption. So the logic here is the name of the data frame, dot group by is the name of the method. The categorical variable is in parentheses. The continuous variable is in brackets. And then the aggregation method follows the dot at the end. Now, of course, you don't absolutely have to have that. You can remove some components. And then you'll get a larger amount of information, but I think it's less useful in some ways. So if we drag this in here, we can remove beer and only keep the categorical variable, and now it will give us the mean of all numeric columns. Some components specifically, you can remove the, you can't really remove the other components. you can group by using multiple aggregation methods. So here I'm going to specify all 6, and then all 6 in one line. So your options are mean, median, min, max, standard deviation, and count. There are actually a couple more, which is by percentiles, but these would be infrequently used, and I am quantile, thank you. Quantile, and then you have to specify which one, like 0.25. Thanks. What doesn't work, and I don't really know why, is mode. Yeah, I would have thought it would be in there, but it's not. So I guess 7 aggregation methods. But if you want all of them in one blow, you can simply type ag, which is short for aggregate, and then provide a list of those. So mean, and median, mean, median, and min, etc. So the .ag allows you to have multiple aggregation methods side by side. And just as we've done previously, since this entire thing is a data set unto itself, you can reassign as short df is equal to this, and then you can do all kinds of things with short df, like short df.head, or you can do short df.shape, or short df, and this is the one that I think is more useful, sort values, and you can sort by mean. But basically, any valid data frame method can now be used on this new data frame. So I'll put in a comment here that says, this becomes its own data frame and methods can be called on it. Okay, enough with group by. Well, no, there is one other thing, of course. You can group by multiple categorical variables as well. It doesn't just have to be one. So going back to here, we had .mean, but you could have grouped by both continent and by country. Well, country isn't really too useful here. You can do that. It's not especially useful, but just generally know that you can, in fact, group by multiple categorical variables. And you can group on multiple continuous variables. So not just beer, but also beer and, say, wine, for example. And that works nicely as well. Or you could do all three of them in one blow, multiple categorical, multiple continuous, and multiple aggregation methods to create like an entire new data frame for analysis. 7:45, 15 minutes. Okay. A few other common features of pandas. Sometimes you may want to change the data type of a column. So right now, let's take a look at drinks beer. Looks like this. And we might wonder, well, what is the data type of that is integer 64. So integer means no decimal places. But what if I want it to be a float, similar to liter? Maybe it's liters, I forget. So liters is a float, beer is a integer. Change integer to float as follows. Drinks beer is equal to drinks beer dot as type float, and then you call and now it's been changed successfully to float, and when I call drinks.head, it'll show those decimal places. So now beer is 89.0. It's gone from being an integer to a float. Or you could change it to a string. As type string. Here I'm going to call this drinks is equal to beer string. And then drinks.head. And now it looks like it's the same, but I can't actually do numerical calculations on it anymore because it's no longer a number, now it's a string.
So, Austin,
Yeah.
sorry, I know this is a dumb question, but this is kind of like so they made the changes, the data change the data type made the change without you specifically saying in place equals true or you signing it to a new data. So it's kind of like a
So here in 108, for example, where I created a new column, I did not need to say in place equal to true because I did reassign a new column, right?
okay.
If I had wanted to reassign beer itself, I could have done it like this. I think you can also do it using in place. I'm actually not 100% sure, but let's give it a try. Let's type and I would do, I don't think this is going to work. Huh. Okay, apparently it does work. I didn't expect that. So yeah, I guess you could have used it here. Does that answer your question? Or at least demonstrate that it's possible?
Yeah, I think so. So you're just creating the 109, you're creating
A new
a
column.
new column.
Yeah.
So
So
that's a new
earlier I
column.
called it beer string, right? Yeah.
Oh.
So I am creating a new column, and I don't need to use in place here. Okay, that's an interesting question. I hadn't thought about it because we are actually modifying the entire data frame by adding a new column onto it. So in a sense, it would have been logical to have both the new column with reassignment and the in place, but we don't.
But just changing the data type of the column, not adding a new column, just changing the data type you don't need to have something in place or anything like that.
So in this first one, I changed it from an integer to a float, right?
Uh-huh.
I don't need to have in place because I reassigned it to itself.
Also, Python understands it's the same column.
Yeah. Though when I do think this is similar to how we saw things previously, in as much as these two lines of code are equivalent to one another. I can reassign to itself, or I can specify in place, and either way, beer's value will get updated. Okay. A good question, and yeah, good question. And by the way, I know you also asked me about .loc. I'm getting to that. I just haven't gotten there yet. I'm skipping a few things here. remap values. And actually, I think I'm going to give this its own section because this is also, after group by, this is probably one of the most frequently used pandas tricks, which is how do you convert or recode a variable into new values. And here I'm going to pull up a second example for some of this. So we've already seen remap, right? We have decided to remap a new variable. Let's try it as follows. Drinks, the map method. Drinks new continent is equal to drinks.continent.map, and then a dictionary where we mapped each of the old continents. Asia becomes Asia, comma, I'm going to give a little bit of white space here to make it more readable. Okay, so we're going to remap AS to Asia, EU to Europe, AF becomes Africa, SA becomes South America, NA becomes North America, and I think the last one is Oceania is OC, right? Go ahead and fix all my tabbing, which is just cosmetic. It doesn't have to happen this way. And we'll go ahead and leave this here. Okay, so here's my map where I've got this dictionary mapping all these values. And I've called it new continent. Oh, yeah, thank you. I'm sorry, it's all in the same dictionary, of course. It's funny, I was actually thinking about the example that we saw in the Plotly Dash app, but that actually was different. Okay, and then we've got the map, and we don't need that. There we go. And now when we call drinks.head, we've got that new continent, and it has successfully mapped the values from the old continent. And this is one way to do it. And that's especially good for categorical variables. Let me add a comment here. Good for categorical variables with not too many values, because you have to obviously specify each one of them. A second method is, I'm not sure what to call this, but using .loc with bins. So on this one, it's a multi-step process. Suppose we want to group beer into low, medium, and high. We're going to create a new variable called beer level, and we specify at the start that it's just low. And if we call drinks.head, we see that now everybody is low, no matter what. Now that we've assigned this variable, we start to break it out using the .loc method, which I'll come back to even more in just a second. .loc applies a filter where drinks beer is between 101 and 200, and also calls the new beer level variable and reassigns all of that to medium. Copy this code, now change it from 201 to 400. Beer level is now going to be high. We run this, we call drinks.head, and we get an error message because earlier I turned beer into a string variable. So I actually have to go back and fix that. By reading back in my data set all the way back up here. Where did I read you in? Okay, so now that I've read back in my clean data set, beer should once again be a numeric variable. And now that works nicely. We've got beer levels of low, medium, and high. And if we call drinks beer level value counts, we see in fact that it is broken up into low, medium, and high. So this is a nice way to break things out and bin it. And it doesn't just have to be the between method. You could have also used a double equal sign or a greater than less than sign, etc. 756. A third method another method for recoding variables. Is the replace method. Suppose I only want to replace one. So this is good for replacing a single value. So right now we've got drinks.continent value counts. And suppose I don't really like Oceania being called OC. I want it to be called South Pacific, so SP. But I don't want to fix any of the other ones. If I were to use map, that wouldn't actually work out very well. Let's give it a try. Change OC to South Pacific and call drinks.head. Now, that did actually work for Oceania, but now every other continent has become a missing value. So .map here is not going to be very effective. There's a better way to do this, which is drinks new continent is going to be equal to drinks continent dot replace and here we're going to replace the old value OC and we're going to replace it with a new value South Pacific, and we call drinks.head, and South Pacific isn't actually in there, but maybe if we do a long sample we'll see it. Okay, there's one. So Australia went from being Oceania to South Pacific. So replace is really, it's like map, but for a single value. And then the last method, good for binary values, binary outputs. So suppose we just want a 0, 1. We want Africa and everybody else. Drinks is in Africa is my new variable, and here I'm going to call a completely new method. It's not a pandas method at all. It's actually numpy. So I'm not sure I imported numpy earlier, so just in case, import numpy as np. It's a numpy method, but it's extremely effective for binarization. Numpy where, or np where. And here you add a filter, drinks continent is equal to, Africa, AF. And then I give it the values. 1 if it's true, 0 if it's false, drinks.head. And now we have is in Africa 0, 0, 1, 0, 1. And it doesn't have to be ones and zeros. You could have a yes and a no, and that would work just fine. The idea here is that it looks at the filter. If it's true, the new variable is coded to the first value. And if it's false, the new variable is coded to the second value. Well, let's go ahead and stop there. That's a lot. I'm going to display a summary of all of this up on the screen. And what I'd like you to do is choose one of the other data sets from the data folder and try running it through all of these steps, especially the stuff at the end, the group by and the remapping and such like. Go ahead and call me over if you've got a question or hit me on Slack. Either way is fine. And the summary is located in a file called summary, which mostly fits up here on the screen. The 4 ways to recode are exampled here. Some examples of how to filter, but most of the good stuff is going to be in here. So let's go with that. And when you've reached a stopping point or you have something that you'd like to share, or especially when you get to the end and you've done some of this LOC method, go ahead and share that output on Slack. In the exercises column, please share your final output here.
So it's just import a different file.
Yes, import a different file. So here I've got the drinks. So instead of drinks, try UFO or something like that.